Hi, George Diamond here. Now today we're starting a new unit in my AP Calculus class. We've already finished chapter 4 in our textbook. That's the fundamental theorem of calculus and integration. Now today we're going to start chapter 5. Now in our textbook we use the laws and text. This is section 5.1, and this involves the natural logarithm and differentiation. So in this particular section we're going to look at how to find the derivative of the natural logarithm. All right? But now before we take a look at any derivatives, I found it always helpful to do a brief review of logs. So let me, I've got a little of my drink here. This is my red brisk fruit drink, I guess. Let me set this over to the side. And let's go and get started. Now this is going to be a pretty quick video. Most students have had logarithms in Algebra 2 and in pre-calculus. So usually by the time they get to a calculus class, they're pretty good with logarithms, but just in case, even then it's been a whole year since we've probably looked at any logs. So we're going to do a little review here with this first video, and then the next video we'll get into derivatives of logs. But first, a couple properties of logarithms we need to kind of review. Now you've probably seen most of these already, but the first property, now this is called the product property, the natural log of a times b. Now in your pre-calculus class, I may have described that as a common log, but in calculus we mainly work with natural logs, right? So very seldom really will we do much with a common log, but we mainly work with a natural log. Now remember, natural log is a base e log. So when you look at natural log x, so if you look at natural log x, okay, that's a base e, all right? So it's a base e natural log, not base 10 like with the common log. So with our first property, now this is called the product property, the natural log of a times b. When you expand this, you're going to expand that as a product, natural log of a plus natural log of b. Now the second property you want to look at is the what's called the quotient property for logarithms. So if you have a division, natural log of a fraction or of a division, so natural log of a divided by b equals the natural log of a minus the natural log of b. So you know the natural log of the numerator of the fraction minus the natural log of the denominator of the fraction, and that will expand it. And then the third property here is what's called the power property, or the power property of logarithms. Natural log of a to the n is equal to, now with the power property, it says if you have if this the answer part of the natural log is raised to an exponent, then you can bring this down front as a factor, and you can multiply this exponent times the natural log. So natural log a to the n is the same thing as natural log times, as n times the natural log of a. Now, there's a lot of instances in calculus where being able to expand a natural log or write it in expanded form will make the problem very easy to take the derivative of. Right? So basically we take a natural log function that at first appears to be very difficult. By expanding it, writing in expanded notation, we can quickly take the derivative of that function. So it's very important with these first three here that you be able to use those three to expand and condense natural log, and particularly natural log functions when we get into the next into a derivative of natural log. Now, two more properties I want to point out. Natural log e is equal to 1. And natural log 1 is equal to 0. So these two, you need to just kind of memorize those, because you're going to see them over and over again as we work with some of these natural log functions. When we get into derivatives, we get into solving natural log equations, you get into natural log e is equal to 1. So this you need to remember, and natural log 1 is equal to 0. So two of these, so you don't want to have to grab your calculator, right? If you need to evaluate natural log e is equal to 1. Natural log 1 is equal to 0. So these two natural logs here, you need to have those memorized. Right? So we need to know those. Now also there are two inverse properties of logarithms that we need to know. So let me point these out. Now the first one says e, if you have a base e, natural log x. So if you have natural log in the exponent of e. Right? So e, and the exponent of natural log x is the equivalent to just x. So keeping the first property in mind, if you see this expression right here, e to the natural log 2x minus 4. Right? So you see this expression here, well, this is equivalent to 2x minus 4. right? So you can drop the e natural log. So what happens where we use this first inverse property is when we're solving e equations, or an equation that has e in it. So if you end up with e, see if you have an equation like e natural log 2x equals, say, e to the 4th power. So you have this type of problem right here. This will simplify then as just 2x equals e to the 4th. Okay. Now our second inverse property I want to point out is natural log e to the x is equal to x. So natural log. Now let me just point this out why this is true. We look at natural log e to the x. So according to the power rule for logarithms, we can bring this x down front, and this becomes x times natural log e. And remember we said natural log e is equal to 1, right? So this becomes x times 1, or just x. All right, so just remember this property here because you see it quite a bit when we're solving equations and things that involve e. So natural log e to the x is equal to just x. All right, so just keep that in mind. So this is a couple properties. Let me just summarize these again. You got the power property. Natural log a times b is natural log a plus natural log b. Natural log a divided by b is natural log a minus natural log b. And then the power property for logarithms. Natural log a to the n power. You bring that n power down as a factor. It becomes n times natural log a. Natural log e is 1. Natural log 1 is 0. So these two here, I said you need to have these memorized. And then our two inverse properties. E natural log x is equal to just x. So you can just drop the e natural log and bring the x down. You have natural log e to the x is equal to just x also. So these two inverse properties come in very handy. They're like shortcuts when we're solving exponential equations and things, working with in calculus. These two here are kind of like shortcuts that'll save us a step or two as far as simplifying an equation. All right, so just several properties. I want to start off by reviewing these a little bit. Now let's take a look at. Now, the next thing I want to take a look at is expanding some logs. Let's take a look at using these first three properties here to expand a couple of logarithms, and then after this we're going to look at solving a couple of equations. Right, and that's going to finish up our video. But let's take a look at just using our properties of logarithms to expand and condense logarithms. Right, so let's start off. Let me get this erased here. All right, so let's see if we can expand a couple of these. So expand, okay, each log. Now keep in mind, these are all going to be natural log expressions. In calculus, we very seldom work with common logs. So we're not going to use log, we're using ln for natural log. These are base e logs. So let's start off with this first one here. We'll do natural log. So natural log x minus 2. So natural log x minus 2 over x plus 2. Now, first thing you want to recognize, this is a division, so we're going to expand this using our quotient property. This will expand as natural log x minus 2 minus natural log x plus 2. All right, so there you go. So if you got to expand it. Now, it's very important that you be able to use the three properties of natural logs to expand. I mentioned this earlier, when we get into derivatives in our next video, a natural log that's written as a fraction like this, in order to take the derivative, you have to be able to expand it. As we get into derivatives, you've got to be able to write it like this in expanded form as a subtraction. Once you write it as a subtraction, then the derivative is easy. Right, so the rest of it's pretty easy. Okay, let's take a look at another example here, number 2. Now let's see, let's try this expansion right here. We'll do natural log square root of 3x minus 2. Let's try this, let's try a radical. Now first of all, let's rewrite the radical in rational exponent form. So my students, I'm sure, by this time, you're used to, we don't even write radicals down. If you see a radical in your textbook, as you write it down, convert it to rational exponent form, becomes natural log 3x minus 2 to the 1/2 power. And the 1/2 power we can bring down front becomes 1/2 natural log of 3x minus 2. And that's all you can do to this one to expand it. So you can write it as the product of that rational exponent. And there you go. Okay, let's try a couple more. And we're going to do a couple of these. Because remember, in this video, you've all seen the logarithms before, or at least hopefully you have. So this is just a kind of a little bit of a review for us. Okay, let's try another example. This will be example number 3. Okay, natural log of x times. So let's see, natural log of, we'll do natural log of 2x. All right, so that'll be pretty good. So let's expand this, it'll be natural log 2, okay, plus natural log x. So 2 times x is a product, so just be, as you expand that as an addition. So natural log x plus natural log 2 plus natural log x. And let's see, let's do number 4. So we'll do this right here. How about natural log of 6x over 5? Let's expand this one here. Now first let's rewrite the quotient. So you got this fraction here. We're going to break this fraction up. So we'll expand this natural log 6x minus natural log 5. And now we still have natural log 6x. The natural log 6x is a product, so we can take the we can expand this as an addition, so it becomes natural log 6 plus natural log x minus natural log 5. So when you get it expanded completely, this is the expansion. So natural log 6 plus natural log x minus natural log 5. Now let's do one more expansion. So let's see if we can do, so number 5 here. Let's try this expression right here. We'll try a more complicated expression. Just do natural log of x squared plus 3 to the second power divided by x times the cube root of x squared plus 1. Now let's try this expression right here. So we'll try a more complicated expression. So when we get into actually taking the derivatives, we have to be able to take derivatives of functions that are written in this form right here. This isn't a function, this is just a natural log expression. But now let's see how we go about expanding it. Now first of all, let's break this fraction up. This will be equivalent to natural log of the numerator, x squared plus 3 to the second power minus natural log of the denominator, x times. Now also this radical, I'm going to go ahead and convert the cube root of x squared plus 1 to a rational exponent. It becomes x squared plus 1 to the 1/3 power. So go ahead and expand that. Okay, also, I notice the natural log x times natural log x squared plus 1 to the 1/3. Now this right here is a product, so we're going to have to expand that as an addition. So I also want to bring the 2 down front on this first natural log. So as we rewrite this now, this becomes 2 natural log x squared plus 3. Okay, now also you got to be very careful now as we expand the denominator here. Okay, this minus sign you have to watch out. So it's be minus this entire expansion. Now we're going to expand that as an addition, so it becomes natural log x plus natural log x squared plus 1 to the 1/2 power. Okay, so this will be minus. Now make sure you get this in grouping symbols as you expand that, right? Because this entire natural log here is going to be negative. So as we distribute this inside our parentheses, okay, I also want to bring the 1/2 down front on this natural log here. We'll bring this one down. It becomes 2 natural log x squared plus 3 minus natural log x minus 1/2 natural log x squared plus 1. So as you do this expansion now, this is what it will expand as. Now in our next video, like I said, we'll have to be able to take the derivative of this type of natural log. And in order to take the derivative, we want to break it down into its expanded form. It'll be much, much easier to work with as 3 different natural logs than it is as the one big natural log. So as a matter of fact, it's virtually impossible to take the derivative without expanding them. So you got to write an expanded notation, and after that we can take the derivative, and I'll show you how to do that in our next video. Now let's see if we can condense a couple of natural logs. So let's see if we can. So we'll just do 1 or 2 of those, and once again, we're just kind of practicing just a couple of examples of our properties of logarithms, how to expand and condense them. So let's see if we can write each of these. So write as a single log. All right, so we'll do a couple of these. We'll just do two these we have to condense. We'll do natural log of x minus natural log of y minus 3. Okay, we'll try this right here. Now, first of all, this is a subtraction, so as you combine this, we're going to use our quotient law. This will be natural log x divided by x minus 3, and that's it. So, fairly simple matter to condense this one. Okay, let's take a look at number 2. So we'll do another one. Let's do 3 natural log x minus natural log y, or plus 2 natural log y. Natural log y minus 4 natural log z. So we'll try this example right here. So number 2. Okay, now first of all, before you try to condensing a natural log, if you have a numerical factor out front of the natural log, typically, always, you want to bring this up as an exponent pretty much. So let's bring this 3 up here. This becomes natural log x to the 3rd power plus, and then the 2 will bring up as an exponent here. It becomes natural log y squared minus natural log z to the 4th power. So anytime you have a numerical factor out in front of your natural log, you want to remove that numerical factor, and you do so using the power rule. All right? So the power law, power property, if you will, bring this 3 up as an exponent now on what would be the answer part of your logarithm. All right. Now, once we've done this, I want to combine the first 2 logs. Now, the first 2 logs is addition. So as you combine those, we're going to combine them as a multiplication. This becomes a natural log x cubed y squared minus natural log z to the 4th. Okay, so minus natural log z to the 4th. Now, let's combine these 2 logs now. So this is a subtraction. So as you combine over subtraction, you want to use the quotient property now. It becomes natural log x to the 3rd y squared over z to the 4th. And we've got it. So as you combine this into one log, this is it. Now, the last thing we want to finish up with, we'll take a look at 5 equations. All right? So a couple of exponential equations, a couple of log equations. So just a couple of equations. All right. See if I can get this erased first. There we go. All right, so let's see if we can solve each equation here. Solve each equation. All right, we're going to do about 5 of these. Now, let's start off with a couple of exponential equations first. So we'll start off with this one right here. We'll do e to the 2x equals 10. So e to the 2x equals 10. Now, typically, remember, with an exponential function, exponential equation, if you will, the variable is going to show up in the exponent on one side of your equal sign, or maybe on both sides of your equal sign. So your variable expression is going to end up in the numerator, or in the exponent on one side or both sides of your equal sign. Now, to get x out of the exponent, we're going to have to use the logarithms and the power property. All right, so you got e to the 2x equals 10. So to get x out of the exponent here, we're going to do natural log e to the 2x equals natural log 10. So we're going to take the natural log of both sides. So remember, this is an equation. What you do to one side, you got to do to the other side. So remember, if you take the natural log of the left-hand side, you got to remember to take the natural log of 10 also. Now, also remember one of our inverse properties. Natural log e to the 2x is equivalent to just 2x. So remember, we can drop the natural log e, right? And that's going to be equal to natural log 10. And then last, we're going to divide by 2. X is equal to natural log 10 divided by 2. Now, I did this earlier, so you can check me on my calculation here, 1.151. So 1.151. That should be our correct answer. Okay, let's try another example, number 2. Okay, let's try another exponential, another e equation, if you will. Well, actually, this isn't an e equation. We'll do one that's not an e. We'll do 3 to the x plus 4 equals 101. So we'll try this one here. This isn't an e. We'll just do a base 3 equation there. So let's try to see how we go about solving this one. Now, once again, remember, we have to get x out of our exponent, so let's take the natural log of both sides. We do natural log 3 to the x plus 4 equals natural log 101. And we're going to bring this x plus 4 down. Now, when you bring this down, we're going to put it in parentheses, natural log 3 equals natural log 101. So bring that x plus 4 down front. Make sure you put it in parentheses now. This is now natural log 3 times the quantity x plus 4. Now, I need to solve this for x. Now, first thing I'm going to do, I want to get rid of the natural log 3. So we're going to divide this side by natural log 3. Natural log 3 is canceled. Let's divide this side here by natural log 3. Now I get x plus 4 equals natural log of 101 divided by natural log 3. And then last, we just have to subtract 4 from both sides. So x should be equal to natural log 101 divided by natural log 3 minus 4. Now, when I did this earlier, I got, for the correct answer, I got 8.201. So 8.201. So you can check my decimal answer there if you want. Okay, let's do one more. Let's do another e equations, number 3. We'll do e to the x equals 5.7. Now, to get x out of our exponent, let's take the natural log of both sides. So we do with natural log e to the x equals natural log 5.7. Now, natural log e to the x, remember, we can drop natural log e and just bring the x down. So natural log e to the x is just x. Now that's equal to natural log 5.7. Now this is the part where you're going to grab your graphing calculator, go ahead and punch up natural log 5.7, and I got 1.704. So x equal to approximately 1.7, actually 740. So 740. Okay, just a couple of e equations. Now let's try a couple of natural log equations that contain natural logs. So let's try this one here. Erase these two. Now let's go do a couple of these. So this is we've done 3. Okay, number 4 here. Okay, let's do natural log 2x equals 4. So natural log 2x equals 4. Okay, we'll try this natural log equation here. So natural log 2x equals 4. Okay, now here's what I'm going to do. To get rid of that natural log, I'm going to rewrite this. I'm going to raise both sides to base e. This will be e natural log 2x equals e to the 4th power. Now what happens, e natural log 2x, if you remember our inverse property, is just 2x. E natural log we can drop. Right? Now what this is, now notice when I write this as e natural log 2x, all we're really doing is converting from the log form of the equation to the exponential form of the equation. So if you look at the log natural log 2x, you've got base e, right? So when you convert the exponential notation, or exponential form of your equation, this will be e to the 4th power equals 2x. So all we've done really is just, whenever we raise both of these to e natural log 2x, you basically end up with the exponential form of your equation. So here we end up with 2x equals e to the 4th power, and then to solve for x, this will be e to the 4th power divided by 2. So x should be e to the 4th power divided by 2. Now when I did that calculation, I got 27.299. So 27.299. Right. And let's do one last problem for this video, and that's going to finish this up for this video. And let's see, one more. This will be number 5. Let's try another natural log equation this time. Let's try 4 natural log 3x minus 2 equals 6. So let's just try this natural log equation here first. Now, to begin with, I need to isolate the natural log 3x. So let's get rid of the 4 and the 2. So let's add 2 to both sides. That gives me natural log 3x equals 8. We're going to divide both sides of the 4 to get rid of the 4 now. So we'll divide. That gives me natural log 3x equals 2. Now, so natural log 3x equals 2. All right, now I'm going to raise both sides here to get rid of this natural log to base e. This will be e natural log 3x equals e to the 2nd power. So we're going to raise both sides to base e. And on the left-hand side, e natural log 3x is 3x. This becomes e to the 2nd power on the right-hand side. And I finish solving for x here. X is equal to e squared divided by 3. Now, e squared divided by 3, I got 2.463. So 2.463. You can check that calculation on your calculator if you want. But just a couple examples of solving a natural log equation. You raise both sides here to base e. So by raising it to base e, you're basically converting from natural log form to exponential form of your equation. Now, hopefully, you found this little review of logarithms helpful. Now, the same properties apply to common logs. So, but in calculus, we almost exclusively work with natural logs. We very seldom do much with common logs. So that's the reason you see the natural log equations and the properties are all in natural log form. And so hopefully you've found this little review helpful. On to our next video now, and we're going to do some derivatives of logs in the next video.